This graphic shows the two's complement number wheel, which is a useful mental model for how the representation of signed numbers using two's complement would work. All right, so the idea here is that we can start with 0. One advantage of two's complement is there's only one representation of 0. Okay, so from there, if you add a number, all right, so I'm going to press the add +1 button, you move clockwise around the circle. All right, so that makes sense. You're adding, you get this flow. And then if you subtract, you move counterclockwise across the circle. So, when I first started looking at two's complement, I thought, isn't it weird that you go from 0 to all ones? Okay, well, it's not if you look at it in this circle point of view, and if you understand the mathematical relationship about how two's complement has subtraction built into it. Okay, so again, subtraction is counterclockwise. So if I wanted to take -4 and add 5 to it, I would go 1, 2, 3, 4, 5. -4 plus 5 gives me 1. All right, so it's moving along this circle. You can see the circle in 3 bits. You can see it in 5 bits. It's a little more crowded in 5 bits. The other thing I wanted to point out is that there are cases where you might overflow. So if you want to show the overflow happens when you go from 7 and you add 1. 7 add 1 takes you into the negative numbers. Okay, so that's an error. All right, that's an overflow error that would need to be detected if you're using two's complement in some piece of hardware. Okay, the opposite direction would be an underflow, where you go from, you're at -8 and you add 1. I'm sorry, subtract 1. It doesn't go to -9. It wraps all the way around to 7, and that is an underflow condition. Okay, so this is a useful mental model of how to represent two's complement along a number wheel.